What's up, Inspired Vision, plus anybody I might be catching on YouTube? We are now on day 9 of our Accelerated Algebra I Summer School course. So today we are solving system of linear equations, which is a very big topic in algebra. So as always, it is time to learn some math so we can get ready for that big STAAR test. Now here's how today's going to work. We're going to do 3 STAAR release questions, 4 guided practice questions, and then 6 independent practice questions where I want you to pause the video and you work out the questions on your own before I cover the answers. Now we are in reporting category 2 and we're doing TEKS 8.3. So make sure you subscribe and like this video and get each of the 18 days of the summer algebra course so you can prepare for STAAR. Alright, now before we get going, I want us to start with this question. We have 3x minus 2y equals 5x plus 8. Now, we are needing to solve for y in this problem, which is what we're going to need to do for each one of our systems. But there's something interesting that happens in this problem that comes up every now and then, but we need to work through our steps either way. So whenever we have to solve an equation, solve an inequality, or solve a system, we first need to ask ourselves, do we need to distribute in this problem? Now, distributing only comes up when there's a parentheses, so no distributing in this problem. Next, we need to ask ourselves, do we have a fraction that we need to clear? And since there's no fractions in this problem, we don't need to clear the fraction. Now, here's what's new. In this problem, we have x's on both sides of the equations. They are considered like terms. I like to draw circles around my x's. You don't always have to shade the circle like I did here, but I'm trying to show you that we are going to move our smaller x and combine it with our bigger x. And the smaller x is the one that I shaded in. Now, I like to say a term here, and the reason why we're doing this, by the way, is because we're used to adding our like terms together. But that's because so far our like terms has always been on the same side of the equal sign, or we didn't have an equal sign to worry about, so we just combined them all together because we were simplifying expressions. But in this case, we have an equal sign. X is on both sides, so I like to say a term or a saying called "take your baby term to your mama term." So the baby term is 3x. The way that I like to take it to the mama term is to do its opposite by subtracting 3x on both sides. Now if we do that, then the x on the left side just cancels. And then we have 5x minus 3x, which are like terms on the right side, which become 2x. So then our equation becomes negative 2y equals 2x plus 8. Now if we're solving for y here, and we're finished combining like terms, the only thing left is to set up our rectangle triangle. But we're solving for y. So that means the rectangle is negative 2, and we have no triangle in this problem at all because there's nothing else on the same side as y. So the x is already on the right hand side, so we don't have to worry about making it the triangle or anything else the triangle. So we only have to get rid of the rectangle, and the way that we do that is division. So we divide everything by negative 2. Now if you take 2x divided by negative 2, you get negative 1x. And then 8 divided by negative 2 becomes negative 4. So we write it as minus 4. Now, right in front of us right now is a linear equation. If I was to graph it, it would be a straight line. It would have a slope going down of negative 1 and start at the y-intercept of negative 4. This lets me know I have a linear equation. What we're doing today is systems, which is taking 2 linear equations and graphing them at the same time. So I have some steps that I want to show you for systems that we're going to do every time we have a systems, and they're these 6 steps. So we're going to approach all of our systems using these 6 steps. So the first thing is we have to make sure we solve each equation for y. The next thing, we're going to plug them into our y equals key. Then we're going to look at the graph. Then while we're looking at the graph, we're going to see if we have both graphs shown. And if we do, we're going to do second trace or calc key, hit 5, and then hit enter 3 times. Now that doesn't always work. So if it doesn't work, we're going to look at the table and see when y1 and y2 match. This doesn't always work. So if that doesn't work, we're going to have to set our equations equal to each other and solve for x. Okay, so that's the approach we're going to take for systems. Let's start with question number 1. Here is a 2014 STAAR question, and they start off by saying the company has fixed costs of $30,000, and each case is an additional $5 a make. So that's the reason why they wrote this equation right here, 30,000 plus 5x. Then they say the company sells each case for $10. That's the reason why they wrote this question. Now the whole point of systems is to find when your two linear systems or two linear equations cross. We can't tell based off this picture, but they did give us enough information that we can figure this out. So we're going to use our steps. We're going to use the same approach. First thing is make sure each equation solves for y. So are both of these equations solved for y? Yes, they are. So then the next thing you're going to do is plug both of these into our y equals key. So your y equals key should look like this. 30,000 plus 5x and 10x in your y2 spot. Then we're going to take a look at the graphs. Well, you only see one of your graphs. So since both graphs aren't shown, this isn't going to work. But since it's your first time maybe doing this, you could try it out for the first time. You're going to hit the calc key, which is second trace. The trace key is right next to your graph key, so it's on the top right, and it's the second button over. And then you're going to go down to option 5, which is intersect. And if you hit enter 3 times on a TI-83 or TI-84, it'll give you the solution normally. In this case, it gives you an error because it only has one graph to pick from, not both of them. So then we're going to do step number 5, which is look at the table. Now, if you look at the table, your numbers, your y1, y2s are really far apart. You might start with 30,000 on for 1, and then you're in the 800s for y2. And as you scroll down, they do get closer and closer together, but it would take you forever scrolling down to get this answer. So this only happens for today, but I wanted to expose you to what you do in case this does happen. In case you can't use your y1, y2 to get the equation, then you set your two equations equal to each other. And what I mean by that is you leave off the y's and you set 30,000 plus 5x equal to 10x. So basically you're setting your mx plus b's equal to each other. All right, now, if this was your equation and you had to solve it, you have to apply the rule that we just did. We have like terms, our x's, on both sides of the equal sign. Now, they are considered like terms, but they're not on the same side of the equal sign. So this is where I say take your baby term to your mama term, which the baby term is the 5x. So I'm going to subtract 5x on both sides. If you do this, now you have 30,000 equals to 5x. And if you're solving, you're now going to set up your rectangle and no triangle in this problem, which means I just need to divide by 5 on both sides. And if I divide 30,000 by 5, I now have 6,000. So 6,000 is your answer. All right, now, what we do today is not going to require this amount of steps. This was the one that was the hardest. So let's go to something that's a little bit easier. This was another STAAR question in 2015. So we have 3x equals 2y plus 14. And then we have y equals negative 6x plus 18. The first thing we're going to do is check our steps. We need to solve each equation for y. Now, which one of these equations is not already solved? Would it be your first equation or your second equation? In this case, it's your first equation. Your first equation is not solved. So we need to solve for y. So we're going to go off to the side, solve for y. Whenever we're solving, this is where we set up our rectangle triangle so we know what to move. In front of my y is 2, and we also have plus 14 on that right hand side. So that's the reason why plus 14 is my triangle and not the 3x, because 3x is already on the other side of the equation. Now I'm always moving my triangle first, so that means minus 14 on both sides. These are not like terms. 3x minus 14 are not like terms, so it does not become 11 or negative 11. We have to write them side by side, 3x minus 14. And for right now, we have that equal to 2y. We still need to get rid of the 2, so we're going to divide all of our terms by 2. And then we need to type this in our calculator. So 3x divided by 2 becomes 1.5x, which you can use that decimal, or you can use 3 divided by 2. 3 divided by 2 is our fraction form of 1.5, and negative 14 divided by 2 is 7, negative 7. So here's my two equations. Because we solved the first one, it came out to be this. The next thing you need to do is plug them both into your y equals key. So notice how I plugged the first equation in. I said 3x, because whenever you have a fraction and x by it, the x really goes to the top, divided by 2. Or you could have written this as parentheses 3 divided by 2, close parentheses x. Or in this case, since it's just one term on the bottom, one term on the top, sorry, set that backwards, one term on the top, one term on the bottom, we could write 3 divided by 2x minus 7. It won't mess us up. And I'll show you more examples of that later. But 3 different ways to write this, or fourth way, you could write 1.5x minus 7. All of that works. Most important thing here, though, is in front of that 6 is a negative sign, and in front of the 7 is a minus sign. Okay, going to the graph. If we graph it, it looks like this. Now this is where what we want. We want to see both graphs in our window. So if we see them, we're now going to hit second trace, go to 5, hit enter 3 times, like this. So here's the calculate. Go down to number 5 where it says intersect, and hit enter 3 times. If you do that, you should have your answer on your screen. It says intersection. And now it says 3.333 repeating as your x, and y is negative 2. This is where our answer is. We just got to think back to what the question's asking us. The question's asking us for the value of x. Well, x is 3.3 repeating. None of my answers are in decimal form like this, so I either need to see which one matches this, or I can do 3.3 repeating in my calculator and turn it into a fraction. Just make sure your 3's take up your whole screen width before you try to turn it into a fraction. Otherwise, it won't do it correctly. All right, so my answer is A here. All right, next question. In this question, we're doing another solution to a system. This time, neither one of these equations are solved for y, so I'm going to have to solve them both for y. So I'm going to set up my rectangle for the negative 7, triangles the 4x, which means minus 4x on both sides first. Put these side by side, negative 2 minus 4x, because they're not like terms, and then divide them both by negative 7. Now, if you were to type this in, negative 2 divided by negative 7 like this will turn it into positive 2 over 7, because it would be a crazy decimal, and we turn crazy decimals into fractions by hitting math enter. And then negative 4 divided by negative 7 turns it into positive 4 over 7, bring down your x. So here's your first equation. Your second equation, set up your rectangle as negative 21, your triangle is 12x, subtract 12x on both sides because that's how we're getting rid of our triangle. Put these terms side by side, negative 42 minus 12x. To get rid of the negative 21, we're going to divide by negative 21 on both sides. Now, if you were to type this in your calculator, negative 42 divided by negative 21, we get a positive 2. And then negative 12 divided by negative 21 is 4 over 7x. So, going through our steps, we're now going to plug both of these into our y equals key. Now, notice how I did this time. I wrote my fraction. I decided not to use parentheses and put my x after the fraction. If it's a simple fraction with just one term on the top, one term on the bottom, you can do it like this. Otherwise, I would need parentheses for the top or bottom or the entire fraction. Okay, so hopefully you have this typed into your y equals key. Looking at the graph, you should see this. Now, these are parallel lines if you did this correctly. Parallel lines means they never hit. We're going to talk more about this tomorrow. But if they never hit, that means they have no solution. So J would be my answer here. Now, the only way you can get infinite solutions is if they were the same equation in both y1, y2, and they drew the line right on top of each other. And a way you can double check this is if you go to your table, your y1s and y2s match all the way down. That's infinite solutions. And then these order pair solutions, that's when we can do this calc, second trace, 5, enter 3 times. Okay, moving on. This is your guided practice questions. We're doing 4 of these, and then you're starting your own. All right, now, they are talking about 25 students in each van, and that can carry 7 students. But instead of us trying to figure out an equation for this, they gave us the equations. So that was nice. Now, what we could do if we were in a groove is solve both of these equations. But I'm going to try to make a point here. Instead of solving both of these equations, we can continue reading the question. And if we read the question, it says, use the graph to estimate the number of vans that will be used. Now, here's the point I'm trying to make is the whole point of doing systems is to try to figure out where they cross. If they give us a picture already, the only thing is we need to put our pen or our finger on where they cross and then figure out what they're talking about. In this case, they're talking about number of vans. Number of vans is on my y-axis. So after you figure out where they cross, in this case, I'm going to draw a line all the way over to my y-axis here. And then I just need to figure out what that number is. Now, you can see they're counting by tens. So the line in the middle would be a 5. So we need a number that's a little bit less than 5. That is the easiest way to do this question since they gave us a graph. Now, we could solve them both for y like I showed you over here. And then put both of these into our y equals key and do calc 5, enter 3 times. That will work. But why go through all this work when we can just look at the picture to get our answer? That's the point I'm trying to make here. Because you will see some pictures, and let's just take advantage of when we see a picture. Okay, here's the second question. No picture on this one. We're given 2 equations, y equals negative 2/3 x plus 6, and y equals 1/2 x minus 1. What we need to do next is see if they are solved for y. Now, both of these equations are solved for. So, no extra work here. Just plug them to our y equals key. Make sure you put a negative sign in front of that 2/3 x and a minus sign in front of that 1. Now next, after you finish putting in your y equals key, you're going to look at the graph. Since we have both graphs on this picture, we can do second trace, 5, enter 3 times. And then we see our intersection. We just take this as a coordinate. The first numbers are x, second numbers are y, and that matches up with answer choice A. Very easy question. Okay. Here are the last 2 questions that we're going to do before you start. So, number 3, we're going to work through the steps. The first equation is already solved, but the second equation is not solved. Since we're solving for y, the number in front of y is negative 9. Triangle is 6x. So we're going to subtract 6x on both sides. We're going to put these terms side by side because they're not like terms, and then divide everything by negative 9. If we take negative 168 and divide by negative 9, it's going to turn into positive 56 over 3. And we're going to want that in fraction form because it's a repeating decimal. And then negative 6 divided by negative 9 is a positive 2/3 x. That is our second equation. Now we're going to type them both into y equals. So we got 11 over 10 x plus 10, 56 divided by 3 plus 2/3 x. No need for parentheses here, although if you're using them, that's just fine. Either way, your graph should look like this. Now, here's a dilemma. We only see one graph when we're looking at it. So we need to now go to the table. If we're looking at the table, we're going to take a look at all of our answer choices and look at what they have for x. So in A, our x is 66. So you could scroll down to 66 and then see if your y1 and your y2 are both 83. Or you can look at B, which is 46, which is a little bit earlier than 66, so you might want to start with this. Now, if B is the answer, then 61 should be in y1 and 61 should be in y2. Or here's 20, which comes before 46. 20 should be the x value, 32 should be the y1, 32 should be the y2. And if you're looking at your table and you scroll down to 20, you see 32 for both y1 and y2. So we know that C is my answer in this case. All right, it's just another way to do this question. And that was a little bit easier than setting them equal to each other, because if you set them equal to each other, then you would have to clear your fractions by the LCD of 30, which you could do. It's good practice if you want to learn how to do this without using a calculator. Okay, now number 4. Number 4, we need to solve the second equation for y. So that means my rectangle is 5, my triangle is 7x. Subtract 7x on both sides of the equation, and we now have 5y equals 22 minus 7x. Divide everything by 5, and we're going to get basically the same thing because this doesn't reduce. Now we type them both into our y equals key. We're just going to make sure to put a negative sign in front of the 1/2 x and a minus sign in front of the 19. Now notice that I put my second equation in first, my first equation in second. That doesn't matter with systems. The only thing that matters is with systems is figuring out where they cross. And if you're looking at the graph, you only see one, so we're going to have to rely on the table. So on the table, I'm going to scroll all the way down till I get to 26, and then I see 32 in both y1, y2. So I know that that's my answer. Okay, now here's what I'm going to do next. You are doing 6 questions where you're practicing this on your own. So question number 1 is shown on the screen. So pause the video until you have the answer. Here's question number 2 and 3. Pause the video until you have both of these worked out. Here's question number 4 and 5. And finally, here's question number 6. Now what's going to happen next is I'm going to show you all these answers. I'm going to quickly cover them, and then hopefully you've only missed maybe one would be a good goal here. Okay, on number 1, you might be tempted to type both of these into your y equals key because they're both solved for y. That is not what you need to do though, because they give you a picture of the graph. And in the picture of the graph, we're looking for how much money would be in either account. Since they're talking about money, money is on the y-axis. So you're looking where they intersect, which is right there, and then looking at the y-axis and figuring out what would be a good number on the y-axis, what that would be, which is 5,200. Another reason why you would not want to type these into your y equals key is because it would take you forever to find that match, but it would be there eventually. Actually, no, it would not. It's just you wouldn't see it because it doesn't cross out a whole number. Okay, number 2. Number 2, you should notice that both of these are already solved for y. So if I put these in our y equals key, making sure I put negative in front of 1/3 and minus in front of 4, then I graph it, I can use my trick of second, trace, 5, enter, which shows me the intersection is of 3, -5, which means I can pick the answer of A. Number 3, I realize it says solve using substitution, but the easiest way to do this is to solve the second equation for y, which means you're going to have 50 minus 4x, and then divide both terms by negative 6, which will come out to be negative 25 over 3 plus 2/3 x. This should turn positive because it's a negative divided by a negative. Put these both in your y equals key and graph it. Now, this doesn't show you the answer because it doesn't show you where they cross on the graph. So we would have to, if we were to do that, we would get an error. So we would have to rely on our table. And relying on our table, we would check all these negative numbers until we see the one that matches. And the first one that comes up is negative 16, and you see a match at negative 19. So you know that's your answer. All right, number 4. Number 4, you should notice that the second equation is not solved. But that means the negative 8 is my rectangle. And there is no triangle in this problem at all because 4x is already on the right-hand side. So that means I need to divide everything by negative 8, which 4 divided by negative 8 is going to turn into negative 0.5. 56 divided by negative 8 is negative 7. Type both of these equations into my y equals key, like this. And we see that they cross. So since they cross, we can do second trace, 5, enter, enter, enter. And then that means we have negative 2, negative 6 as our answer, as C. Same thing on number 5. We're solving for y. So this time we have a triangle of 2x. We're going to have to always move our triangle first by subtracting 2x on the other side. Putting these terms side by side because they're not like terms. And dividing by negative 9. This is going to give us a positive 2/9 and another positive 2/9 x. Now I'm going to type both of these equations into my y equals key. Look at the picture, and we see that they cross. We can use second trace, 5, enter, 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 and see that the intersection is negative 1, 0 to be C. Okay, last question for today. Again, we might be tempted to put these into our y equals key, but we're looking for how many seconds where the intersection is. Seconds is on the x-axis. So looking where they cross, that would hit at 5 seconds. Now, if you were to type this into your y equals key, you would see the answer. So you can double check it that way. Okay, so I hope you enjoyed today's lesson. This is our first lesson on systems. We're going to continue doing systems tomorrow. So I hope you tune in tomorrow. Thank you.